Oh, hey, what's up? Today, we're going to learn a little bit about smart contracts and deploy your first contract. How's that sound? So, like I said, today we're going to talk about smart contracts. I'll give a brief overview on what a smart contract is and where they came from, and then I'm going to walk you through deploying your first smart contract on Polygon using Solidity and Remix. And don't worry if you don't know what those things are, because I'll explain those too. So you might be wondering, what is a smart contract? Well, a smart contract is basically just a computer program that can execute automatically and save transactions or agreements without the need for a trusted third party. They were first proposed in the 1990s by Nick Szabo. He used the analogy of a vending machine to explain what a simple smart contract is. You see, with a vending machine, you put money into the machine, and then it does one of a few predefined things. It dispenses the item you selected and any change needed. If you selected an out-of-stock option, it will ask you to make a new selection and then repeat this process. It can just give you your money back if requested, or it can start dispensing until your honey bun or bag of Doritos gets stuck in that little metal spiral thing and the alarm starts going off when you bang on the machine to try to get it to fall. In all of these cases, the machine handles the entire transaction without the need for any third-party human interaction. In Web3, these smart contracts are executed on a distributed blockchain, most commonly the Ethereum blockchain. But smart contracts are also available on other blockchains, including Solana, Polygon, Polkadot, Avalanche, Tezos, Cardano, and more. Executing these smart contracts on a distributed, decentralized blockchain has a number of benefits. You get some security, transparency, and verifiability in the execution of the smart contract. When a function is being run in a smart contract, it has to be verified and confirmed that the execution achieves the same result on many different nodes in the network. The code of these smart contracts are most often open source too, so anybody can go and read what the actual code is and determine what the execution result should be. Even more powerful is that the data and the state of the program is open and transparent for anybody to see and verify. These properties lead to one of the most powerful engines of Web3, composability. Anybody can build on top of or add on to existing programs permissionlessly. Nobody can stop them. These smart contracts are also typically immutable and cannot be changed once they're deployed, though there are some ways to implement an upgradable smart contract. Essentially, smart contracts are the Legos or the building blocks of Web3, and they power the programs behind decentralized apps. So now that you know what a smart contract is, how do we deploy one? We're going to deploy our smart contract using Remix, which is a development environment or IDE for smart contracts developed by the Remix project. Remix allows developers to learn, test, and deploy smart contracts on Ethereum and Ethereum-like blockchains, which are known as EVM-compatible blockchains. Blockchains like Polygon, which is what we're going to be working with today. Remix makes it easier to develop in Solidity. Solidity is a programming language for smart contracts. It's the language of Web3. Sorry, Rust. It allows us to write and run programs on the blockchain. It's based on C++, Python, and JavaScript, and it's designed to run on the Ethereum Virtual Machine, or EVM. You can also run Solidity smart contracts on any EVM-compatible blockchain, like Polygon that I mentioned before, or Avalanche. So now that you've had a little introduction to all of the pieces that you need to deploy a smart contract, let's do it. Okay, so the site that we're going to want to go to is remix.ethereum.org. I'll highlight it up here in the URL bar. And that is where the Remix IDE is. It's a browser-based IDE. And if you open it up, this is sort of what it'll look like. So if we hit Solidity, it'll kind of show us our Solidity compiler, which is what kind of compiles all our code into something that the Ethereum virtual machine can read. So let's look at what we can do to create our first contract and deploy it. So if we see, we'll click on contracts, and there are already some existing ones in there, but we're going to create a new one. So we want to right click, hit new file, and let's call this basic contract.sol. So .sol is the Solidity extension. So the first thing that we're going to want to do, it usually complains if you don't have an XPDX license identifier, and that's basically just to identify your open source license if you have one. I usually just do MIT or something. To be honest, I need to look up and learn more about the different kinds of open source licenses. The next thing we need to do is specify a Solidity version, so we do that with pragma Solidity, and then I think we need to do greater than or equal to 0.8.0 less than 0.9.0 contract, basic contract, and let's see if that compiles. So I just hit Control S to compile it, or you could go over to this compiler and hit compile basic contract, and that seems to have worked. So now this contract, we're really not going to do anything special. I just kind of want to show you how this works. So here's what this contract is going to do. It's going to save the name for an address and the age for an address. So it's going to allow somebody to basically call the contract and set the name and age for the wallet address that they're calling the contract from. So to do that, the first thing that we're going to want to do is create a mapping of the address to the string. So a mapping is basically like a dictionary or a lookup. So it is a way for us to say, look up this address and tell me the name associated with it. So to do that, we'll do mapping, and then we need to do address to string, and then we want it to be public, and we're going to call it address to name. And then we also need another mapping for the address to the age, and the age is going to be a number, so we're going to specify that by a uint 256. That's just basically the largest number that's possible in Ethereum. Obviously, nobody's going to live to be that old, but just to be safe, we'll use uint 256. And then we'll call that address to age. Okay, great. So now if we compile this, let's see what we get. It compiles just fine. And we can actually go, and if we hit this tab, the third one to deploy it, we can deploy it to actually deploy it to the blockchain. We're going to use this injected Web3, but while we're testing, we can just test it in the JavaScript VM. So if we do that and we hit deploy here, we can see down here that the VM transaction went through. And then over here on the left, we can expand the basic contract and see that we have these two mappings that we just added, address to age and address to name. So when we copy our address up here, we bring it down to paste it in, and we don't get a result. It's empty for everything. So we see that it's empty for everything, but we haven't really added a way for a user to change that or to add their name or age. So we're going to have to add a couple of functions to allow the user to do that. So we're going to add a function called edit name, and it's going to take a string. We're going to declare memory just because that basically means that the string is only stored in memory and not saved permanently to the blockchain. It's a little bit faster and cheaper. And then we're going to want this to also be public, because so basically what the public keyword means is that anybody can call that function or see that variable outside of the contract, which we want any user to be able to add a name or age. So we want this to be public. And this is going to be a really simple function. Basically all it's going to do is go address to name, and then we're going to do this little message.sender thing. So message.sender, all that really does is give us the wallet address of the person who is calling that function. And then we're going to set that equal to the name that they passed in. And we're basically going to do the same thing for age. So I'm just going to copy that. Need to remove and then make it edit age. Obviously it's a number and not a string, so we'll change this to UINT 256 age, and then address to age, and change this to age. And let's see if that compiles. And that seems to have compiled just fine. So let's get rid of these old contracts and deploy. All right, and now that we've deployed that contract, we can see we have actually two new functions here, and they're orange instead of blue. So blue is basically just like a variable that you can call, and the orange ones are functions that actually perform something or change the state on the blockchain. So let's add an age and call that. So we'll do 29 and then click edit age, and we'll see down here we have our contract. And then we'll add a name, and it goes through again. And now let's see if we can get the return value correctly there. And it says 29, and here we get my name. So it seems to be working correctly, and our contract does basically what we said it was going to do. So how do we actually deploy this to a live blockchain? Well, I'll show you how to deploy it to the Polygon blockchain right now. So if you go up here to environment and click injected web3, it'll use whatever browser you're using here. I have my MetaMask. Oh, it's going to open Coinbase wallet. I want it to do MetaMask. And I'm going to have it use not the Ledger one, just to make it easier, since I should have enough Matic there to deploy the contract. And since we're on Polygon network, so we'll do next. And we'll allow Remix to connect. And then we're going to just double check and make sure that we're on Polygon here. So your account is not connected. That's okay. We want to switch to this account. And we're on the Polygon network. We're connected here. And basically all we have to do, so this doesn't matter. If it was the Ethereum network, all we would need to select is Ethereum here. It's just too expensive to do this kind of test stuff on Ethereum. So on Polygon, here we are. And then we're going to hit deploy. And basically all it's going to do, you'll see it brings up my MetaMask and asks me to sign a transaction with the estimated gas. And I'll hit confirm. And we'll wait down here. Creation of basic contract is pending, and it completed. So how do we know our contract completed? Well, we can go into our MetaMask and see that in our activity we have a contract deployment. So let's click on that contract deployment, and let's go view our contract on Polygon Scan, which is their block explorer. Basically the Etherscan of Polygon, if you've heard of Etherscan. And here we are. We have our contract deployed, who it was deployed from, and If we scroll down a little bit further and go to this 2, to the contract, we can open up the contract address. And let's see if we can decompile this. So I didn't set myself up yet to actually verify my contracts for the code. I don't necessarily know if we even need to look at the bytecode to be able to call the contract. Let's go through the process of how we set up verify and publish. So if I don't have an account, I need to set up a Polygon scan account. So I'll set up my Polygon scan account. Well, we'll use a different email. We'll set this up. And then we'll be able to verify our contracts so that basically they go through and everything is open source and readable and open to be transacted with on Polygon Scan. So I need to get my email verification, so I'll be right back with that. Okay, now that I got in, I'm going to go to verified addresses and add my MetaMask address. Just copy it over here. Oh, we need the contract address. Sorry about that. So just copy that. And let's verify. Solidity single file. Compiler version, we were using 8.7. So we come over here and do and we can copy it all. Verify and publish. And now if we refresh our contract on Polygon Scan and we click on contract, we can see the code. But not only that, we can also read off the contract. We could put our address. We can put our address in here and see if anything has happened. Let's see if we have a name. Nothing yet. And we can write to the contract, so we could add that name now. So let me add my name here. And since it's live, it's going to, Polygon Scan wants to connect a provider, so it can't just inject from MetaMask. So let's connect my wallet. There we go. Oh. Do I need to refresh the page to get it to go? Let's first make sure that we're still empty here on the address. And if we go here and do that, connect Web3 provider, connect to Web3, MetaMask. And we're connected, so we'll hit that. And it will bring up our estimated gas, and to confirm, we could view our transaction that just went through, and then we can go back, query, and we get our new result. Now that the contract is compiled and deployed on the Polygon network, we can also open our contract in Remix that's deployed on the Polygon network still and mess around with it. So you'll see here, I had actually made these changes on Polygon Scan with my wallet and updated it to Kyle, and now I can come on Remix and check the state of my contract on the blockchain, and it has that change in here. But I didn't add an age yet over there, so it's still coming up as nothing. So let's add the age here in Remix. It's going to pop up MetaMask for me to confirm the transaction. So I'll confirm it. And we're waiting down here, pending. And it's through. So now if we check the age again. Oh, am I using the wrong address? So I need to actually grab... Oh, I think that's the right address. There we go. And it takes a few seconds sometimes for all the blocks to update and for the data to update. But there's our result. So now we've deployed our first contract to Polygon, and we're kind of well on our way to beginning the journey of Web3 development. And now that we know about smart contracts and Solidity, and we've deployed our first smart contract, the world of Web3 is really wide open to us. But there's still a lot to learn. I, myself, feel like I'm at the bottom of the mountain just starting the climb. While I'm going to keep bringing you educational videos like this and showing you more about the building and developing side of Web3, I also want to share with you some of my favorite learning resources. So here are some of the places that I've been learning from and that I've found super helpful. The CryptoZombies tutorial from Loom Network. This tutorial basically shows you how to code in Solidity by taking you through building a blockchain game. And as part of that, you learn about NFTs and smart contracts and all about decentralization. The FreeCodeCamp Beginner to Expert Solidity tutorial on YouTube. This video is a masterclass in everything Solidity and smart contracts from Patrick Collins. It's free for you on YouTube. It's super long and in-depth. It's 16 hours long, but you'll learn basically everything you need to learn to become a competent Solidity developer. The official Solidity documentation. As with any programming language and framework, the official documentation is always one of the first places that you should familiarize yourself with. BuildSpace is like a Web3 community where you can learn with others in cohorts. They have a lot of different projects set up, everything from minting your first NFT to learning how to write a smart contract, and you do those as sort of a cohort working on the same projects. And use Web3, which is just a massive collection of different learning resources from around the web. It has everything from tutorials to different apps to use to videos and documentation and even full-length books. I'll leave links for all of these resources below if you want to dive into learning about Web3. And now that you know how to deploy a smart contract, I hope to see you building some really cool things in the Web3 world. I'd love it if you could subscribe, and feel free to reach out with any questions or if there are any topics that you'd like me to cover in Web3.